Welcome to GDP's Physics and Simulation 1 2019. My name is Felipe Bellini and this is a video demonstration for the final exam, addressing the classes lectured by Michael Finney at Fanshawe College. The final exam explores concepts such as axis-aligned bounding boxes, collision detection, and the vertex shader. An extended document providing answers to the questions of this exam is available at the root of this solution. Moreover, you can also find a README file and a controls file in there. Open the final solution in Visual Studio 2019. This simulation should load a skybox with the Star Destroyer at its center. Moreover, we'll also see the X-Wing ready for battle. Although this solution might take a while to load because of the large mesh files of the Star Destroyer, there shouldn't be an impact in performance, because since we are using axis-aligned bounding boxes, we don't have to check a lot of triangles and so on like we did in the first projects. So here's our scene. We have our X-Wing, we have our Star Destroyer. Let's click here to see what we got. We have our bounding boxes. If you press F4 on the keyboard, you should see all of them. So there's only bounding boxes on the Star Destroyer. Some of the triangles of the Star Destroyer are too big for the bounding boxes, so I have to use the technique where we slice the triangles and keep adding the triangles to multiple boxes. So this works. And if you press 2 on the keyboard, we should see questions 2 and 3, where the X-Wing will follow a path, and if this path comes close to the Star Destroyer, then the X-Wing will shoot a green bullet towards the Star Destroyer and then immediately turn back to its origin of movement. So I'm pressing 2 on the keyboard so we can see the X-Wing moving towards a line. We can see that it's far from the Star Destroyer, and that happens frequently because of the random nature of the positioning of the ship. So there's no way to control this because it's random. The lines will stay in place for about 5 seconds or so. So we have our movement. Again, because of the random nature of the paths, I put some keys for testing this in an easier way. So if you press B on the keyboard, there will be a hard-coded path, and we should see exactly the behavior that was asked during the final. So if you press B, then we can see the X-Wing flying towards the Star Destroyer, and you saw that there's green bullets going towards it, and it should hit soon. Let's wait for it. Okay, so you can see the triangles on the screen, right? So these triangles are being drawn and there's a collision. So it collided at the end of the path. There is a small red dot that's a sphere, as it was asked in the final. We can see in in the console that the console logged that there was a collision between a triangle and the bullets at a certain box at a certain distance. And then it says the sphere was positioned at this location. So yeah, it's an interesting project. You can keep trying. Press 2 to approach the Star Destroyer. It will happen. Oh, this is close enough. So let's check this. We should see the same behavior as before. The X-Wing will shoot. The bullets will crash against the Star Destroyer and the X-Wing will turn back. There's the shooting, and the X-Wing is turning back, and we wait for the collision. There's the collision. We can see the triangles on the side of on the Star Destroyer. The console logged again. That's great. Let's go to questions 4 and 5. Questions 4 and 5 also deal with collisions between objects and the axis aligned bounding boxes. But in this particular point, we are going to focus on the deflectors at the top of the Star Destroyer, and we are going to see some visual effects using the vertex shader, and we're also going to deal with health, losing health until something happens. So let's try this out. Again, this will heavily depend on the random paths to do that. So to show this feature working for the video, I made available 2 test buttons, much like I did for the collision for the other point of the video. So now we can use letters M and N on the keyboard to shoot towards the deflectors and see some feedback on the console and on the title bar of the OpenGL project. Doing this, shooting like this, you can see that the deflector 2 lost some health. Let's do that again for the first one. So N shoots towards the first deflector and M shoots towards the second deflector. So because I'm reusing the bullet, we have to wait to cause damage in the deflectors. We can't have multiple bullets flying around. So I'm trying to lower the health to 0 so we can have the very last part of our exam, that is the shader effect. We can see in the console printing the health going down, and if I press M again, we should see an effect where the Star Destroyer explodes by using the offset in the vertex shader. Okay, great. So here we go. In the console we have a message saying that you've destroyed the Star Destroyer, and that's it for the demonstration of this final exam. We're going to take a look at the code now. We're going to see a little bit of the things that I changed for the shader and the whole update loop thing. So let's move on to the code. Moving on to the solution, we can go to game and see some files here, but before diving into game, I'd like to show the mesh class that I have, which is important for the ABB generation. Oh, it's big. So one of the methods we have here is the get bounding AABB, which follows Michael's code that was presented in class, with some modifications like the ability to slice triangles. So what happens is that if you have a triangle that is larger than a bounding box, then we might fail in tests if we don't handle this properly. So what this code does at this point is that it checks if the triangle is bigger than the axis aligned bounding box, and if it is, then slice the triangle into fourths, and keeps doing that using recursion until the triangles until we can fit all the triangles inside the bounding box. But the takeaway with this is that we don't add the sliced triangles, but the very same triangle is added to different boxes, and that sort of closes any gaps that we might had if we didn't handle that before. So that's in the mesh class. So let's go back to our game project. So in the game project we have some important classes for this. So we have a class for the X-Wing, a class for the world, for the Star Destroyer, and for the bullet. So the world is the most important class here. It handles all the interaction that we're seeing in our physics simulation. So basically we have this update method, which is called by the main or the game loop each frame. Here we can see some basic control for the ship, like drawing the path that we generate randomly. We check if we have some logic checking if the X-Wing is in range of the Star Destroyer or things like that. So we have an appropriate response here, which is shooting from the X-Wing and then inverting the X-Wing direction. Then we have update methods for all these objects that I'm creating in the solution. We have calls to the GPU manager that draws things on the GPU. Here we have some collision detection thing. We shouldn't see this on this solution, but if that's the case, we can also collide the X-Wing against the Star Destroyer, and then, much like in Project 2, the X-Wing will stop. We have here some comments regarding question 4, testing if the bullet collision hit the deflectors. Then some calls to the draw in the GPU manager. Here we have a piece of parts of question 5 where we are destroying the Star Destroyer. Notice there's an overloaded call to the draw the book for object for final, which is a specialization of the draw call that I did for this exam. Yeah, so here we have it. Some methods here have the name of the questions for easier look. Like here we have question 2 for testing, which is the button B. Question 2, where's the regular workings for that. and so on. Yes. In each specifically special object, you have prepared code to handle its own things, like the Star Destroyer handles damaging into its deflectors. Also has an update call, calls updates on the deflectors, game objects, and so on. We also have our shader here. So here I'm opening inside assets, shaders. So the change I did was inside the vertex shader, where I have an ability to set the shader, the offset shifting in the shader or not. So we have a bool variable and then a float variable. If this bool variable is true, then we're going to multiply the vertex position by its normal, and then this offset we're passing. So each frame, this offset will increase by 0.05 floating points, and then it will see that effect where the Star Destroyer blows up on the screen. So yeah, this concludes our presentation for the final exam. Thank you, and for more information, you can contact Michael Finney at Fanshawe College, or myself, Felipe Bellini, also at Fanshawe College. Have a great holiday season, and see you next year.